imagine you have a black box. That black box is your language model, is your AI. Initially, how it works is that you feed a couple of words at the input of that black box, and then the output, it will predict the next word. So what you can do is, for example, at the input of that black box, you can put, what is the capital of France, ? And then the model will predict the next word. So the next word that comes after this can be, for example, the. And then you will again feed that at the input, and the model will predict the next word. So a language model always, in this case, these types of language models we are working with today, is always predicting the next word in a sequence. And if you continue this, so what's the capital of France, ? The, then it will predict the next one. The capital, then the next one of is France, is Paris.
Great.
So yeah, that is the most. So in this case, we have been working with a model that is already trained. The black box already has all the knowledge inside of it. Now the question can also be, if I now have a black box, so we go a step deeper. Imagine now you have this black box, but it's empty. It doesn't know anything. You want to train it, you want to teach it the human language. That can be English, German, whatever.
But what do you mean it doesn't know anything?
So, in the first example, when we were looking at this black box, it already knew human language. It knew how to understand sentences, it could answer questions, it could do a lot of things. So it already possessed a lot of knowledge inside of it. But now in the second step, just assume that there is no knowledge. We need to train it. So it is just an empty black box, and we want to train it. So how do we do that? How do we in fact train a language model?
You mean there's a black box that can kind of predicts the next word but has no true understanding?
Yeah.
Yeah.
It doesn't know anything. So it will predict next word, but the words will be random. It doesn't know, has no knowledge inside of it.
Yeah. Got it.
So these language models are trained so that you take a very large corpus of text. And very, very large in this case means like billions or even trillions of words. You would almost go and collect all the data that exists on the internet. So you would go through every web page that exists, and you would take the text from that web page.
Yes.
Once you have that, you would just concatenate them all into one giant stream of text. And that stream of text would have millions, billions, or trillions of words. And then what you do, you feed the first word in that sequence to your black box AI. And you ask it to predict the next one. So let's again assume that our first sentence is, what's the capital of France? I am feeding the words, what is the capital of France, ? And now the model should predict Paris. But because at this point the model has no knowledge, it predicts something random. It maybe can predict, I don't know, London or New York or whatever. So if the model makes a mistake, I tell it, no, that is a mistake. The correct answer is Paris. Learn from that. So update, change your parameters so that you predict Paris next time. And next time it sees the sequence, what's the capital of France, it will predict now Paris. And in this way, you just continue. So my giant stream of text, that is trillions of words, at every point, I'm asking the model to predict the next word. If it's wrong, I tell it, no, that's wrong. Here is the right word. Learn from that. And I just continue.
Yeah. And by wrong, you mean in the text or the corpus that you've taken off the internet, that the model is not predicting the same way that as the text that is in that corpus.
And the corpus you take from the internet is extremely varied.
Yes, so that's what I was going to say.
Yeah, because you might have examples where in a forum somewhere or on Twitter or I don't know where, someone asked really the question, what's the capital of France? But you can also have examples, I don't know, there is maybe a website somewhere that is teaching math. And then what you can have on that website is that there is an example of 2 + 2 = 4. And then this model will take basically the tokens 2 + 2 =, and I will ask it to predict what does it equal to. So the model is also learning to predict that 2 + 2 = 4. Basically, it's learning a bit of math. And in the same way, you will have probably some medical data somewhere.
Yeah.
So that the model is also, I don't know, someone is asking somewhere about a disease, or there is a research paper presenting a disease together with symptoms, medications, or they are presenting a rare case or any of that. And the model will go through all of that and learn to correctly predict the next word. And by doing that, it will learn about the subject.
Yes. And I think just to add to this, I think that's really interesting. So it basically learns by mirroring or learning from text that's already on the internet. And sometimes that's good quality text, right? And sometimes it's not, like you said, from Twitter or often from Reddit. A lot of these models take a lot of text from Reddit. And sometimes the text there is maybe not the best or not written in the most intuitive way. But also, as a clinician, I also understand that, medicine is a language in itself. Like, we use a lot of very specific words, which you wouldn't normally use in the human language. And it's mixed in with a lot of Latin and Greek. So it's amazing that the model can learn and that there is that kind of text out there from textbooks and from papers, like you said. But one shortcoming is obviously the way we write in hospitals is also its own language and its own slang, and that is not very well represented on the internet because obviously a lot of this is confidential data, and there's not much in comparison to the millions and billions of text that's the model's trained on. There's not much of that kind of text out there, right? There's only some data sets which have been anonymized. But yeah, it's very interesting. So I think as a clinician, I think there's already some things there in the training that I'm not fully comfortable with, or that I see could cause problems further downstream.
I think the main problem is exactly as you mentioned, is that there is a lot of data that is just wrong.
Yeah.
When collecting these data, you're not very discriminative. You're just like, give me everything. I want as much as there is on the internet. And by doing this, you will also collect, a lot of these forums, a lot of information on Reddit, or simply a lot of information online, especially about medicine, is simply wrong. It is like, that is why the first thing when you Google "my head hurts" is you have cancer. You don't want that. Yeah, exactly. You don't want the model to learn that. You want the model to be like, oh, that's a headache. Maybe just take some painkillers. There are still many problems.
Yes, there's lots of problems. And I guess just going on that very last point you made about, reinforcement learning, I imagine you'd need to provide a lot of nudging, because there's so many things that you could talk about with the model, right? So you can talk from, geography to science to medicine to art. Do you think you need to be kind of reinforcement learning? Do you need to give it reinforcement in each domain and each aspect?
In general, it should not be like that. If we are talking about these models being able to generalize from one domain to the other, or if it knows about 3 domains, maybe it can generalize to another 20. So it should not be the case that I need to nudge it for every single domain. Which is obvious. Even with ChatGPT, we can be sure that when they were training it, they did not train every single domain in existence, but it still works for almost any domain relatively well.
Yeah. Why don't we talk about, so given that pipeline you've just mentioned about how we can train a language model, let's try and think how we could align the model to a clinician rather than a general human. So, how we can align something to a doctor. So going back to very first principles, when we mentioned you can train a model on all the text on the internet. Instead of doing that, theoretically you can train a model only on medical corpus, or have a larger proportion of medical textbooks or medical corpuses, so then the model has a more intuitive understanding, or give the model more medical data to learn from. And therefore you have a better base understanding of medicine. But you also keep the other stuff, right? The general knowledge, but also just a higher proportion of medicine.
This is a very good example because I've tried these and I've done these. I've done these, in fact, with the GPT-3 model. So before ChatGPT came out and all of that. And I took one of the existing models. I couldn't take GPT-3 because that one was not public, but I think it was Neo GPT or GPT-J or something, one of those. All of these are just variations of the model, so you don't have to worry about the names and all of that.
Yeah. What happened?
Yeah, I took one of them. I trained it on King's College Hospital data. So I took all the clinical notes. I had the exact same idea you just had. So I was like, okay, if I train it on clinical notes and if I train it on discharge summaries and all of that, so basically hospital data, it will be so good because it will have medical knowledge.
It's funny you said discharge summaries, because that's notoriously often the worst written document in hospital, because it's often written by the most junior clinician who has probably the least input or understanding of what's been going on with the patient. But yeah, okay, I'm interested. So what happened after you fed it these valuable discharge summaries?
So the model was worse than it was before. It became a mess. The model was writing in a style that did not make any sense. It was breaking sentences in the middle. It started making spelling mistakes. I was like, what is happening? It became a complete mess. It also started writing in abbreviations. I could not understand what it was saying anymore. It did not use like full sentences. It started using strange symbols and all of that, and everything went wrong.
You're describing, the reason for this is because sometimes, especially in a busy hospital, like I said, discharge summary is written by the most junior doctor often. And sometimes if you're so busy in the week, the discharge summaries pile up. And then if you're a weekend doctor or a doctor late in the afternoon, sometimes you'll be asked to write up all the discharge summaries. So, often there's many discharge summaries waiting for me to do back when I was a junior doctor. And in order to try and get through it as fast as I could, sometimes we make mistakes, and sometimes the summary is not the best quality documents. So it makes perfect sense. So in a way, GPT actually learned exactly what it was supposed to learn in the discharge summary.